Assalamualaikum warahmatullahi wabarakatuh. Today we will proceed with our series of lecture for BQS502. Today's topic is on large span buildings, okay, which is a part of the chapter of building enclosures. So, a general consideration of a large span building. There are a couple of them listed here. First of all is the location of site, elevated access, safety, assembly and storage areas, weather and site instructions. So first of all, the location of site. So these large span roof, okay, are often used in stadiums, hall, factories, and other buildings where people can assemble in large number. So normally when we talk about large span buildings, it will involve the construction of large span roof. Most of them likely uh, do not want to have any type of obstructions. Okay, whether it is for the views of the audience or for the placement of equipments and materials. So the construction of industrial building is ordinary and hardly attracts attention because let's face it, these type of buildings are not the uh, eye-catching as other types of building. Others are prestigious in nature, such as football stadium, exhibition halls, and places of worship. So these are the large span buildings which have a lot more flair to them. So normally they will be given a lot of attention in terms of their construction, in terms of their designs and such. So some buildings are located in built-up areas where the original buildings on the site had been demolished for new buildings. Okay, so these are some of the redevelopment projects. Such site will face the same problem associated with high-rise building in congested site. So there will be problems such as logistic restrictions, trespassing, security, safety, in terms of complaints from neighbors, those kind of things. Okay, so the project team has to come up with a way to resolve this matter. So if the building is large, prestigious construction, so normally they would have a lot of cost penalties if completion is delayed. Okay. Next is in terms of elevated access. Uh, Large span roof have the high headroom of from 10 to 15 meters high. So 10 to 50 meter. 50 meter is very high. Okay. So whether the roof is assembled complete or in portions at the ground level, then lifted to its final position. So the way they are going to build this large span roof, okay, is either they are being assembled at their final position or they are being assembled at the ground level, very near to their final position, and then being lifted and installed at their final position. Okay. However, the second method is the more what you call safe method. So elevator access such as ladder, scaffold, and hoist have to be erected. Mobile scissor lift. So these are some of the equipment that they utilize in order to install and maintain those elevated roofs. We have mobile scissor lift. platforms. We have also crane. This is to lift the materials. And then in case of suspension structure, so they would have to pull themselves up to the roof and abseil down. So this involves the issues of health and safety. So hoist will be impractical because of the cables. Okay, so this has to be delicately installed. The workers have to balance themselves on those cables that are already been installed, so the other cables may be installed. So when they have installed the primary structural cables for the roof, and they will have to install the secondary and tertiary cables. This is when we need those workers. So normally, this kind of job are reserved for the specialist contractors and specialist workers. Okay. So mountain climbing skills are useful for roof installation. Some builders install temporary catwalk on the cables so workers can move safely. So in terms of safety, obviously we are working at heights are dangerous, so they have to have a lot of safety measures to prevent accidents and death due to falling objects and workers. So at certain intervals, they would install safety nets, and the workers who are working at height would have to use safety cables. Okay, so what else? Safety policy has to be rigorously implemented on site. And then we have the assembly and storage areas. So the production of structure is either in situ or prefabricated, so that depends on the type. RC, large span roofs are still being used for elevated water reservoir roof. These are some of the types. Okay, so they are no longer popular for roof of stadiums and halls because the development of material technology. We have other types of material that we can use that would last as long as the reinforced concrete roofs. And then roof covering has to be inspected after installation. So they have to walk and physically, visually inspect those coverings. And roof with curved surface make it difficult to walk. Okay, so workers have to have their safety lines installed and being used all the time. So two possible approaches are this I mentioned earlier. Either first of all the roof being fully assembled at the ground level and then lifted up by crane or jack or winch to its final position. So the assembly area is near to the final position. So this provides a lot of access for the workers to install the roof, and also is a lot more safer. The second approach is by assembling the roof in portions. So each completed portion is lifted to its final position by crane and temporarily supported. So the roof portion could either be on the ground, directly below on the ground, or not far. Okay. So those are the two solutions. In terms of the component, it must be transported from the factory to the where it needs to be installed. So this limits the size of the components. We cannot have a very large component. And then this component will be stored and will be inspected. And then this requires a large areas and on site to store this component. And then the contractor has to also provide suitable assembly area for the final installation of the roof. Other elements have to be installed first, such as spectators or sitting terraces. So this may prevent the assembly area of the roof to be directly below the final position. So they have to move a bit to an assembly area, not directly beneath, but near its final position. So over here you can see that this is the roof structure, and then we have this temporary support or temporary column to support this roof while it is being constructed, and it will be taken out once the roof has been completed. So next is in terms of weather. So obviously rain, wind and lightning can affect the rate of progress of erecting a large span roof. You do not want to be doing any heavy lifting works, especially in this kind of conditions. So rain will soften the ground and may prevent the transport of the components to their respective lift-off areas. This could increase the risk of crane falling down or toppling because the soil is too soft to support the loads exerted by the crane on the ground. So, and then wind, rain, and lightning will prevent this of crane and endanger workers. Roof structure is also vulnerable to collapse, so you do not want to be doing this long span roof construction during the rainy or thunderstorm season. So vulnerable to collapse during high winds. So that's why they would have all those temporary structures to provide extra support to the uncompleted roof. Next is site obstructions. So a restricted site will create problem in terms of logistic, providing space for assembly. So here the project manager has to be able to make use of you know of the available space on site. Okay? So it must be remembered that the crane must be tall enough so that a lifted roof component may be able to clear parts of the roof or superstructure. So over here we can see that obviously there's a lot of cranes and they are overly very high, okay, so that they can lift the material over the structure of the stadium itself. So and then they make use of the playing field area as an assembly point for their works. Next is the dome construction. Okay, these are special buildings. So basically, the dome is a three-dimensional arch. Okay, so the arch is one of the strong components or elements of the structure, widely used in the ancient times to create large span roof. So the roof covering was placed over a row of arches to create a large span roof. Okay, so this is the second oldest method of providing a roof that has great span. Okay, so these are some of the ancient and old buildings where they use the concept of dome but with different types of materials. Okay, so start off with masonry dome, RC dome, steel dome, air inflated dome, glue laminated dome, and suspension structure dome. So this is the Blue Mosque in Turkey. A very beautiful construction which has multi-level domes. So several structure methods are used to create the dome roof. So these are some, sorry, some of the types of domes available. The rib dome consists of arrangement of rib members on a ring beam support that converges on either a crown connector or crown compression ring. See, we have okay, so that is the ring beam that we are talking about. Okay, so if it's way at the top, it's known as the crown ring. So the ring beam support is needed to prevent splaying of the rib members. Columns or load-bearing walls support the ring beam. So the columns here are known as the ribs. Okay, so let's see. Okay, so these vertical components, they are known as the ribs. So the rib members are constructed of hot rolled steel sections. This is depends on the design of the buildings. The material for the ribs can be anything. Okay. So the rib domes, the framework of the rib members must be braced to provide rigidity, thus resist the winds, loads acting on the finished dome. So the rib members are being connected together by this ring beam. Okay. So you can see that you can consider the rib as the columns and the ring beam as the actual beam. So they need to be they need each other in order for the dome to be stable. So purlins are installed on the ribs to support the roof cover. Okay, this is exclusively for the purpose of placement of roof covering. Membrane, okay, either made out of steel sheet, geotextile, fiberglass, polyester, ceramic panels, is attached to the purlins on the ribs. The membrane provide weatherproof roof. Okay, cover over a dome. A false dome ceiling is then attached to the underside of the framework. And okay, so that is the example. This is the structure itself. Obviously, there will be a lot more ring beams. And the dome again depends on the design. Next, we have the grid domes. So this is an innovation from the flat grid roof types. See, we have, yeah. So this is the grid dome. So a grid framework is curved to provide the dome shape. So instead of a flat grid, we now have a curved, okay, rib. So it becomes a dome. A ring beam is provided at the base again to transfer loads of the beam to the supporting column, wall, or the foundations. The dome can either be single layered or double layered. So typical grid, either a lattice grid or a space grid. The roof cover membrane, again, is attached to either purlins. Or if you do not want to use any purlins, it can also be installed directly to the grid. So this is a grid dome that uses steel for the structure and for the, let's see, for the finishing. Okay, it seems to be using glass. Okay, and then lamella domes. Okay, so this is an example. It's a type of a grid roof. It looks like a grid dome. However, grid dome system will use connector component for assembling the longitudinal grid components together. So the lamella members are joined together without using connector components. So it connects are usually pin jointed. Okay, so the grid network has a diamond or rhombus or triangular pattern. So it is the difference here is just in terms of connecting the members, where lamella domes does not use any type of connectors. Okay, another example of a lamella dome in large scale. Next is the geodesic dome. So this is an example. So of course it's still a grid roof. Looks like lamella and grid domes, but the difference lies in the configuration of the grid line. So the grid line follow pattern of points of intersecting geodesic lines. So the difference here is just in terms of the lines. So geodesic line defined as a line that circumvents the surface of a sphere. The points where geodesic lines crisscross each other are known as geodesic points. Members of geodesic frame are not geodesic, but the position of their connections are geodesic. Meaning that the geodesic domes are different only because of the design, not because of the use of connectors or in terms of the design of the lines. So it's just in terms of design. So the grid members are either double or single layer. The members in geodesic zone are joined together without connectors. So they also do not have any connectors, and because of their uh, very oddly shaped lines, they can be called geodesic dome. Okay, another example of a geodesic dome. Next is the shell domes. Okay, so this is an example of a shell dome. So this is the oldest among the types of domes. The principle is that of a stress membrane due to its shape, masonry was used to create a membrane. Use of RC and then reinforcement cement allows for larger span. And then they have a tension ring beam located at the base. And then the thickness of the dome reduces as it approaches the crown. So the thickness of the dome. Okay. To reduce the weight of dome, the crown may be windowed hole that is lined by a compression ring beam. So we also have a ring beam at the top and the sides. Okay. So these windows allow light to come in, and this type of dome is less used together. It's not as economical. So the construction of these shell domes are not as economical as other types of domes, but it is truly a unique type of dome. Okay, so with that, we've covered the topic of large span building and domes. So thank you very much for tuning in. Hope to see you again. Assalamualaikum warahmatullahi wabarakatuh.